and see it. Should I have posted it? Sometimes it's 20 minutes before the meeting, but you know how it is. It's the way life is sometimes. So, any other questions, comments? All right. Bob Armstrong, introduce yourself, and you're on.
I'm I'm Bob Armstrong, and definitely some interesting uh, talks. One of the things, first of all, is this font big enough, or should I go to supersize? Uh, I yeah. Um, yeah, actually, let me start with, oh, that's last month. One of the issues of having a live notebook. Yeah, here we go. Um, and I'll put down a timestamp. F11 puts down a timestamp. And so it's all about having a timestamp live. Um, Yeah, give me a 2-minute warning to show you sort of current state of things. But one of the things is notes on. It was very interesting, Bill, to go and hear your background in uh, running mutual funds and so forth, because I of course come from the well kx.com is the actual uh, CoSy evolves directly from Arthur Whitney's K and kx.com. And I think I remember they were, anyway, they're Manhattan and actually, of course, global, but uh, it's the APL that pulled me first east to Xerox to well, I ended up rewriting their worldwide forecasting system, but then pulled me down to Manhattan because one of the things is if you're good at number crunching, whatever your druthers are, the numbers that are most valuable, instantly valuable to crunch are ones that have currency symbols attached. Um, so it was very interesting to go and see. I started having making these comments. Uh, I the issue of um, um, objects versus, well, APL started off as rectangular arrays. Um, but I've had this discussion with Alan Kay actually, who gave a great talk at APL 79, actually, and too few saw, but on Small Talk. But I've had the discussion with him that what objects lack is the notion of the geometric arrangement of data. And of course, that's where the APL side of things was, and evolved to KX, which is a major global contender, and now is getting into their CEO is giving some interesting perspectives on AI because the fundamental data structure of KX, which is what the fundamental data structure, the lists of list structure of CoSy is. Um, oh, yeah, and with respect to that, the header in a CoSy object is essentially just this three item thing. First, the first cell is type, um, and that essentially determines the vocabulary that's applicable to the type. And count is how many. So that allows you to essentially go and say, do it on all of these. And then reference count actually handles the allocation and freeing. Essentially, when it allocate, well, the reference count when it returns to zero, it frees the space. So it frees the address space. Um, so and so you can make any type. I mean, there are only a few types, uh, just ints and floats and characters essentially. I had a type dictionary, which is actually the sort of thing that really makes it a dictionary is a list of two lists, names and values. And one of the things actually in type zero is a list of lists. It's a list of arbitrary objects. And it's the non-zero things that are things like floats. And so you can say, okay, do it on, fundamentally do it on all of these. And one of these working down here. Oh, with respect to time, obviously, if you're involved in any sort of accounting thing, is an extremely fundamental sort of a thing. And one of the sorts of things that's a traditional, way back when I wrote CoSy and K around 2000, it was that um, I can't remember what. Well, just yeah, it's all about. Oh, yeah, the sort of thing that K would do is go and show what trading, week in the last decade was like most like this week, so we can predict what tomorrow's prices will be. Um, and one of the things is, and this is something that came, following learning curl after the earlier discussions on, I now have these words, uh, which to go and get things and put things on the web. Um, then getting down to Brad's talk, which just again, it's this mapping of math arrays to silicon arrays is sort of something that's a long-term notion, and a couple of sort of things that I was doing just to go. Brad was making, has these arrays of columns of well, symbols and so forth. So I just wanted to show, I mean, I've got alphabet sitting around, and this goes and just takes it as a 13 by 13 structure. So you got, and actually, if I go and do this 13, I have a three-dimensional array where I've got the alphabet split in half and so forth. But that's what you can do in just at a thought. Also, he had this thing where he's got a set of numbers and they all have a particular suffix, but CL goes and concatenates and then this uh, this is dyadic applied, and I happened to pull up earlier this list of iterators, which is now in help, but each of these is essentially a form of a loop. But this is one of the aspects of having a language at this math level, is that if you have a an FPGA and you want to distribute this computation across the processors, there's no implication that in fact this is implemented as a loop. And as a matter of fact, earlier I was putting down, oh, well, yeah, some interesting links that, well, Jeffrey Hinton, who I've been in the same room with back at Northwestern, has a very interesting YouTube on the very earliest language models when he was doing it back in the 90s. Um, but there also have been a lot recently, and this gets to the FPGA thing and also the parallel thing. I've been getting a lot of links to papers about doing well parallel processing and convolutional um, oh, neural well convolutions essentially on arrays. I guess the term is convolutional neural net. Yeah, convolutional neural nets. Yeah. And that again is the sort of thing that, I don't have multidimensional convolutions, although Dialog APL does. Um, but in any case, the ability to just express, when you can express something in a word, and of course, one of the attributes of forth and APL is that if you have a thought, you can just simply define a word. The word that adds to your vocabulary, your flowing vocabulary, and other languages. You got this notion of a program, as opposed to just creating language. But in any case, there have been a significant number of AI papers. But this whole point, this thing on people going and implementing these parallel convolutional sorts of algorithms, which is all these lines that are going across like this and intersecting the ones like this, and then going and talking to the nearest neighbor, which actually is sort of on Techie Dome. Oh, I'm definitely not following the order of things, but I am sort of following the I wanted to pull it up over here. Um, oops. Um, in Techie Dome, I have these answers to this is really annoying that it does that. Um, Dialog APL has these APL Mondays, and in general, I go and respond to them, and this is the APL, and this is really what it does. But one of these gets into this notion of the shifting to the right, actually, and getting transitive closures. It was called transitive closure, and actually, I ran into a problem in CoSy and instituting transitive closure. But that's one of these things of, okay, you're going from link to link to link, and like in a Markov chain, right? Just a lot of these sorts of things are very, very general. Working down here, yeah, and going and being and showing that here you've reduced things to just a thought. You write it down, and there's a lot of vocabulary. And no, there's something I didn't quite get to. Okay, here's um, uh, Boolean representation, which I saw you sticking on things. Oh, and it also is an interesting, with Brad going and essentially describing uh, the these what are now computer structures. About the first major use of APL at IBM with Ken Iverson and Iverson and Falkoff was to go and give a description of the IBM 360. So again, have a language where it is a matter. Actually, I shortened this. Oh, that's why the iterators were up. I must have hit it earlier. But those iterators, each of those iterators is turning a paragraph into a word or into, well, actually, the brilliant thing. I'll pull it back up. Um, the word that makes all of these work is tick. So tick, the fact that you can return the address of a verb rather than having it just execute goes and allows you to pass that on to a next a following word. So these which are called operators in APL or adverbs, I like that term that Iverson got into, um, are just words that take verbs that take verbs among their arguments, and of course, there's no limit on that with in fourth. So there's tremendously more flexibility here than in any of the traditional um, paths. Let's see, first use, iterators. Oh, and one of the things is there's a sense in which I've always put this as the combinatoric application of verbs to nouns is sort of a fundamental goal. And of course, that's in a sense what you need when this is you that's why you have things coming from the left and right and mixing with each other. Um, but yeah, it's combinatoric application. Um, I'll interject. Actually, one of the things that's interesting is that Iverson, of course, started with the notion of working from a matrix up to three-dimensional or arbitrary dimensional, but always rectangular data sets, and the very and actually Bacchus, I think. Bacchus mentioned Iverson in Bacchus's and John Bacchus's Turing Award talk. And in that talk, he talks about the fact that, well, these rectangular data sets were, to put it a little more formally, they're not generic. And they really can be represented as just lists of lists. And that's what the structure, I mean, Arthur Whitney went there. I followed Arthur Whitney on that. Um, and so that makes the header everything, that simple. It's just type to let it know what it is, and type 0 means it's a list of more recursively nested lists. But if
Nominal
they're
end in 2 minutes, Bob. Bob, nominal end in 2 minutes. We're going to stop the
yeah,
recorder more or less at that time. We won't
yeah,
stop you mid-sentence, I promise.
I'll just go and then close with this. Dave Thomas, he was actually chief scientist at King, which is just an incredible sort of a thing with that menagerie. But been talking to him in emails, and one of the things he mentioned, what's the difference between a founder and an entrepreneur? An entrepreneur can sell, and that's my challenge at this point in time. But let me jump down because I went through all of those links, which are kind of interesting. But one of the things now, oh, and if I hit an asterisk followed by a timestamp, that means my clock is off. And now I've gone, and this is following these getting curl and so forth. But I execute that line, and among other things, it grabs my password from my main um, my everyday diary, but I won't show you that, which I did my mistake before. But now I've got it reduced to, so if I execute that, F6, all these notes and everything are now uploaded to the web. I was going to show actually now because I've not gotten a real. I can't believe people have not. Nobody's got a good suggestion for a WYSIWYG HTML editor. Now I've really started doing that in CoSy, and with that, yeah, I will go and execute two more lines. Yeah, here is the code for the my home page that I've now gone and but one of the things is if anybody is editing whatever, it's a really pretty the vocabulary is quite strong for that, doing that sort of thing. And with that, I will stop sharing. So that's my update.
Okay, that was Bob.
Yeah.
And are there any questions that are quick? All right. With that in mind, thank you, Bob. I appreciate
Have a
your
good
content
lunch.
contributions. Let me ask Brad to pull the plug on the recorder with due on ceremony. See you that are joining us at the treehouse shortly.